Welcome, Form 4, Physics, Topic 6, Optics, Notes, Lesson 1. First, we learn convex mirror. Now, this convex mirror, it is made from a sphere. It is made from a sphere which I'm going to draw in 3 dimensions. It is made from a sphere and I'm drawing this in 3 dimension 3D. And of course, any sphere must have a center of sphere. And this center of sphere in optics, it is called the center of curvature, symbol C. C is the center of the sphere from where we are going to make the convex mirror. And that convex mirror, I can take the right hand side as the convex mirror. That means I have to look from the right hand side, looking over here. Or I also can take from the left hand side. That means I must look from the left hand side. Okay? This is the convex mirror in 3 dimension 3D. So this is a convex mirror, or this is a convex mirror. And this convex mirror, which came from a sphere, I'm going to draw this in 2 dimensions. So the convex mirror in 3 dimensions, I'm going to draw this in 2 dimensions. I'm going to take the right hand side. So now the convex mirror will look as part of a circle. This was the inside part of it, of the mirror. And we are looking from the right hand side towards the mirror. And this is the mirror. Okay? Of course, the convex mirror. Now we are going to learn a few terms regarding this convex mirror, a few terms. The first thing is the center of curvature. If the sphere has a center of curvature and from the sphere we got the convex mirror, that means the convex mirror here must have the center of curvature. So I'm going to rub off the 3 dimension sphere and focus on the 2 dimension. We are going to focus on the 2 dimension. So this convex mirror, it must have a center of curvature, which I label as C just now, C. That is a C. Okay. The first term that we are going to learn is, before that, let me rub off this, the eyes. Okay. So now, this convex mirror has a center of curvature. Keep in mind, the center of curvature, it is the center of the sphere from where we made the mirror. Number 1, the first thing, the horizontal line passing through the center of curvature, it is called principal axis. I'm using all short forms to save time. The horizontal line passing through the center of curvature is called principal axis. Okay, that's number 1. Number 2, for this convex mirror, we are going to draw a vertical line. We're going to draw a vertical line, which I'm drawing here now. So this vertical line represents the convex mirror. Okay, number 2, that was number 2. Number 3, you remember just now, I said the C is the center of curvature, which is the center of the sphere, which means now the distance the distance between the center of curvature and that horizontal line must be the radius of the sphere. Because C is the center of the sphere from where we made the convex mirror. So the distance between C and the vertical line representing the convex mirror is the radius R. Okay, next, we have a point on the principal axis which we call the focus point F. Okay, it is a point on the principal axis which we call the focus point, capital F. Next, the distance between the focal point to the vertical line is called the focal length, small f. Okay, so we have the principal axis going through the C, and the distance between the C and the mirror or the vertical line is the radius R, and on the principal axis we have a point called F, focus point, and the distance between the focus point and the vertical line is the focus length or focal length, symbol small f. Okay, now there is a relation between the F and the R. There's a relation between the focal length and the radius, and that relation is that the R is 2 times of the focal length. Of course, we can say this, that the F is same as half of R. Okay, which means if this F is half of R, that means this distance and this distance must be same. So I can label, if this is F, I can label also this, this as F. Okay, and therefore this point C, the center of curvature, I can label it also as 2F. So the C, center of curvature, also I can label it as 2F. And keep in mind that the radius R, I also can put as 2F, 2 focal length. Okay, these are all the terms. Now, what am I going to do? On the next lesson, I'm going to explain what are the properties of the light ray for convex lens. That is, let me rub all this off. So if I were to have a convex mirror, I'm going to draw the vertical line, and this was the principal axis. I have to shade this. So we are actually looking from here. Now what am I going to do is that, what happens if a light of ray reaches the mirror? Parallel, reaching the mirror. Okay, there are 3 properties. Of light ray. 3 properties of light ray for this convex mirror, which I will explain in lesson number 2. Thank you.